All right. Like I said, today's going to look very familiar, but kind of viewing it through the eyes of, well, first of all, just remembering these types of topics with particle motion, but also then through the eyes of using integrals to find these. We will have 3 examples. The first one is as such. A particle is moving along the x-axis. Its velocity is given by v of t equals 38 minus 4.2t. And we are supposed to find the following. Part A, when is the particle moving right, left, and stopped? Part B, what is the displacement? And part C, what is the total distance? All those words should sound familiar. We've talked displacement before. We've talked total distance before and the difference between them, but we will continue to kind of remind ourselves what those are. We haven't talked particle motion in a while, but remind ourselves of part A. What is it about our velocity? Well, I guess I shouldn't even say velocity. What is it that tells us right, left, and stopped? Yeah, the velocity specifically being positive, negative, and 0. So how am I supposed to show that? Again, one of the things is that we are indicating how that is starting. So I would organize my thoughts very clearly here. Right, my velocity is what? Positive, right? Greater than 0. So when 38 minus 4.2t is greater than 0, left would be when our velocity is then negative or less than 0. So 38 minus 4.2t is less than 0. And stopped. What has to be true about our velocity for our particle to be stopped? Has to equal 0, right? This particular problem is also just a great one to look at. We have to slow down and take care of the algebra rules that we know that if we're going way too quickly through this one are definitely going to catch us and hurt us in the long run on this one. When I am solving this first one, first of all, grab your calculators and find the value of t for me. It is AP, so we should be rounding to 3 decimals, which should be a given at this point, right? Less than, right? Did we all catch that in our solving? Something that is frequently forgotten because we get going so quickly through things and we know the motions and we try to skip steps here, but we divide by a negative in this inequality, right? And when you divide by a negative in an inequality, you must flip the sign. So we are moving right when time is less than 9.048. On this other side, then obviously we would be at, again, it's the same number, so 9.048, and when I divide this time, it's going to be moving left when time is greater than 9.048, and would be stopped, obviously, at that moment of 9.048. Okay, so up to that point, are there any questions? Now, there is one thing that we always have to keep in mind when our problem is involving time. So there is actually one thing about our answers that I think we need to adjust. Think about it for a second up there. Any thoughts? Time can't be negative. Time can't be negative, right? So where would time end up being negative? When it's less than 9.08, so we need to kind of stop it on the other end, right? So this is going to move right between 0 and 9.048. So that is, again, one of those things that we just have to step back and say, okay, I'm not just a robot solving an inequality. What is that variable representing? It is time, and time can't be less than 0. Time cannot be negative, right? Okay. Now let's do, aside from this problem, let's remind ourselves of the whole topic of Displacement versus total distance traveled, okay? Displacement talks about where did I start my journey compared to where did I end my journey. And let's say our journey starts at, and I've used this example a ton of times, but if our journey started at Elkhorn South, and we went down and visited Gretna High School, and then we drove up to Elkhorn High, okay? Displacement would be 2 miles, because it would be where we started to where we ended, okay? And it would be that we moved 2 miles. Total distance would be starting here, whatever it is, 10 miles to Gretna High School, plus the 12 miles to Elkhorn High. So total distance would end up being 22 miles. So difference between displacement versus total distance. Any questions on that part of it? Okay, so then what does that actually look like as we write up here? Remember the title of this is using integrals as net change. Comparing our displacement is just the integral. Displacement is going to equal the integral of that interval. So for the first 10 seconds, displacement just totals up, finds all the area, taking into account the positive and the negative, right? That's what integrals do. So we would have the integral. Now, let's, again, do a good job of showing our work here. So we're going to do the integral of our velocity, 38 minus 4.2t dt. If I write this, that is not notationally correct. We have not identified a variable of integration. I wrote that on a lot of people's quizzes, okay? If you have an integral, you have to have a variable of integration. So we are doing this with respect to time. Any questions on that? Okay, let's go ahead and grab our calculators. Math 9. What's our displacement? 170? Any questions on that? Good so far? Okay. And then total distance needs to take into account the fact that some of our movement was right, some of our movement was left, some of it was positive, some of it's negative, right? As we're thinking about this up here, some of it's positive, some of it's negative, or right versus left, and we need to break our integrals to represent those different times. So the integral that our particle is moving right would be from 0 to 9.048 of our velocity function, and you can fill that in, or because it is defined up here, you could just refer to it as v of t dt in there. This would represent how far our particle moves to the right. And then we would have a second integral that would represent how far it is going to move to the left. And the sum of those two numbers is going to give us our total distance traveled. Okay, so we move left starting at 9.048, and it didn't say up here when to stop, but it does ask us on that interval. So it's from then to 10 seconds, again, of our velocity. So you could just fill in your velocity this way, or you actually could represent it as v of t dt. Again, because it is defined somewhere on our piece of paper, it's defined for forever as that, so I can fill in both. Now, we have talked about you have two options. The integral of that left one from 9.048 to 10 is going to be what kind of a number? Negative, right? Because our velocity is negative. It's below our x-axis. So this is going to be some negative number, but if I'm looking for total distance, you have two options. Subtract it, so you're subtracting a negative, or my preference, which is a total personal thing here, absolute value. Okay, that is up to you, but somehow you have to indicate that you know that you will be changing the sign on that integral. Any questions on that? This would absolutely be a point on your AP exam. Let's, again, practice our good setups showing all of that. I can't just magically have a number listed, or I probably lose a lot of points on this. Okay? So this part maybe not so much we would need, but I do think you would do each of these individually, and I forget what this was 170 something. Most of our movement was to the right. Okay, so again, I'm going to make this one positive by taking its absolute value, which, comparing it to my displacement, I know that this was 1.905, right? I know that because we would have subtracted this and gotten to 170. So now I do add those together. 173. Yeah? Did my mental math correct there? Okay. Now, I do want to show you a little tie here to our fundamental theorem of calculus because, do you remember, we've done questions like this with displacement and total distance before, and we talked about the displacement. Do you remember this from a long time ago? Displacement was if we were to find the position function, which maybe we started with on a problem like this because it was before we knew how to take integrals, that our displacement function, displacement of that particle would have been the position at the top of our interval, which would be, in this case, 10, minus the position at the bottom of our interval, which would have been 0. Does that look familiar? Okay. We would have done that a long time ago and talked about, and then we broke it into the moving right, moving left, and we would have done each of those little intervals independently. Well, guys, this is exactly what was evaluated when we did the integral from 0 to 10 of v of t dt using our fundamental theorem of calculus, right? Because this is the antiderivative of our velocity. So you see the tie? We were doing that before. We just didn't realize we were actually using the fundamental theorem of calculus. Have we found distance before this? Yes, and it would have looked like this. We would have known the position function, and we would have said that the position at 9.048 minus the position at 0 would have been our distance moving to the right, plus the position at 10 minus the position at 9.048 would have been how far we moved to the left, and we would have added those two numbers together. We would have found our little displacements on each of those intervals and added them together. Which again, fundamental theorem of calculus is exactly what's happening up here. There's that, knowing now that our position is the antiderivative of our velocity on the x-axis. Your particle is moving on the x-axis. Yep. Any other questions on this? Similar style question on this next one. It's just a good chance for us to do a little bit of review of trig/unit circle stuff. Okay, so I'm going to let you work ahead of me on this one a little bit, but same kind of setup. Particles moving on the x-axis. Its velocity is given by v of t equals 6 sine t. For 0 is less than or equal to time is less than or equal to 2 pi. Find when your particle is moving right, when it's moving left, when it is stopped. And then we'll move on from there to find our displacement and our total distance. So the concept for each of these questions is the same as we just talked about on the last page. We've already discussed that our particle will be moving to the right when our velocity is greater than 0. Our particle will be moving to the left when our velocity is less than 0, and it will be stopped when our velocity equals 0. I'm going to start on that last one. So as we talk about this, our velocity is the function 6 sine of t. And if I want to know when that equals 0, we have to think about our unit circle. You can use inverse trig on this one. If I were to solve for t, the first thing I would do is divide by 6. Well, 0 divided by 6 is 0. Okay, so we're thinking about when is sine of t equal to 0? Or when is inverse sine equal 0, which is the same question. Okay. On what places, at what angles on the unit circle does sine equal 0? 0 and 180, which is pi. Now, careful on this one because there's actually one more answer based on how they wrote their interval at the top. 2 pi, right? Because they included 0 and 2 pi, 2 pi is another place that sine would be 0 on that interval. Now, with that being said, this is not as straightforward to just like solve an equation. I know that those are the places that it's going to be stopped, probably changing directions. So think about this again as far as what we know about our unit circle. The function 6 sine of t, again, is just our sine graph vertically stretched by 6. When is it greater than 0? When is it going to be above our x-axis, or when is it positive? When is sine positive? Or in what quadrants is sine positive? 1 and 2, right? Sine is positive in 1 and 2, which would be from 0 to pi. 0 to pi. So I went back to what I know about my unit circle. Sine is positive from 0 to pi. Sine is negative then in quadrants 3 and 4. So that would be from pi to 2 pi. We've talked about this before, but some of you, again, may not have been introduced to this before, but you do need to know where your trig functions are positive and negative for situations just like this. There is a very common mnemonic device out there. All students take Calc. Tells you where things are positive. All things are positive in quadrant 1, sine only in quadrant 2, tangent only in quadrant 3, and cosine only in quadrant 4. Okay. Finding the displacement is just like we did on the last one. So our displacement is just the integral from the start to the finish, from 0 to 2 pi, right? We're just comparing where did it start, where did it finish. Putting in our velocity function, which is 6 sine of t dt. That absolutely would need to be shown on a problem like this. We're not going to just grab our calculators, type it in, and give an answer. When I do grab my calculator and type it in and get an answer, sometimes it's a little bit alarming. Weird, maybe. But then we think about it, and it's not going to be weird anymore. But what is the answer? 0. Well, that has to do with the symmetry of sine, right? Does the same amount above our x-axis as it does below our x-axis as it completes one period from 0 to 2 pi, and that's what we're looking at. So the amount of area in that time above our x-axis and below our x-axis are exactly the same, giving us a displacement of 0. A number in front of the t with multiplication. A horizontal shrink or stretch of that. Okay. Then total distance goes back to when it is moving right, when it is moving left, and we would break our two integrals based on those intervals. So from 0 to pi, it's moving right. Moving right means I'm going to get positive values, a positive value for that area. And then moving left would be starting at pi going to 2 pi. And again, that's going to give us a negative value, so either subtracting our left integral or absolute value symbols there. And then if you grab your calculators and type that in, we get what do we get on this one? Not 0. Yeah, because that's going to be a positive. Yeah. So we get 24 as a total. We get an area of 12 above our x-axis. We get an area of 12 below our x-axis. Up here, that was 12 minus 12, which ended up being 0. And for total distance, we would be like total area. Same idea. We add all areas as if they are positive and get a total of 24. Questions? All right. The last one, also a common thing that we're going to see on our AP questions, and this is really going to mess with our heads for a little bit here, and then we will fix it in a little bit. A car moving with an initial velocity of 5 miles per hour accelerates at a rate of a of t equals 2.4 t miles per hour per second for 8 seconds. We will eventually. We will eventually. How fast is the car going when the 8 seconds are up? Let's talk about that one first. We're going to sometimes see that question, how fast? Another word for fast, it would be like, what is the speed? And we've definitely heard that one before. Speed equals what? Absolute value of the velocity. It's the velocity, right? We're looking at the velocity here. So that's what our question is going to focus on. How fast is the car going when the 8 seconds are up? Means that we are going to find the speed of the car, and speed is equal to the absolute value of the velocity. Okay. So going to find our velocity function, because that velocity, the derivative of velocity equals our acceleration function. That means we can find the integral of our acceleration, and that will give us our velocity function, right? So our velocity function then would be, if our acceleration is 2.4 t, its antiderivative would be 1.2, right? Undo your power rule here, t squared plus c, right? So right now I have that my velocity function is 1.2 t squared plus c, but they give us an, I should underline this word, that's key, initial velocity. Initial velocity indicates what? Time equals 0, right? So at time equals 0, our velocity function equals 5. Initial conditions, I can go find our c value. So 5 equals 1.2. Okay, Again, thinking back about our tests and grading our tests, guys, when you do something like evaluating an integral, you have to show the constant of integration. Has to be on there. And this, you have to show this. You can't just go do it. You can't just have magical numbers show up. You have to show in a very organized fashion that we are using our initial conditions. And doing so, that becomes 0, c is 5. And we get a velocity function of 1.2, oops, I need an equal sign in there. 1.2 t squared plus 5. You can show this a couple different ways. We can show then evaluating that at time equals 8 seconds. Plug in 8 to that. And we get 81.8. 81.8 what? Miles per hour. Velocities in miles per hour. Our independent variable is in seconds. T is in seconds based on what they gave us for A of t, right? Miles per hour per second. And that's what's going to be our big discussion on this next one. How do we deal with that weird phrase, miles per hour per second, when then trying to find our antiderivative to find our distance traveled? Okay. So how far did the car travel in those 8 seconds? So that would be total distance, right? And it doesn't really matter because our velocity is some positive number being squared, or something squared, which will be positive, plus another positive number. Isn't our velocity always positive? Which means it's always moving in a positive direction. We only need one integral. We don't have to break it up into positives and negatives on this for how far did it travel. And during those 8 seconds, it means from 0 to 8. Of our velocity function. Okay, so grab your calculators and evaluate. I need a number first, and we'll talk about then our label second. Thank you. Now, typically at this moment, because our variable that we were working with and our function inside of there, usually we're labeled using the same units, like miles per hour and hours. Our hours for the miles per hour and the hours for our dt would have just crossed off at this point. It would have been miles per hour times hours, or miles per hour times our variable here, which is hours, and those would cross off, and we usually just get left with miles. And we haven't really talked much about that, but it is not this time. Our first label here is miles per hour, which I'm going to write this way just to show you that is miles per hour. Our label on time, though, was in seconds, and they don't cross off. So I'm not just at that. We did not travel 244 miles in 8 seconds, right? That does not make sense, does it? Okay, so we have to go back to, I don't know what year you guys learned this in science, like physical science maybe. It was a lesson called dimensional analysis, where you learn how to convert between mixed units, okay? So dealing with mixed units, I can do this in a couple steps, or if you happen to know how many seconds there are in an hour, I need to get rid of my time units here. Okay? Does anyone know how many seconds there are in an hour? 3,600? Okay, so this would be multiplying by 1, right? 3,600 seconds is the same as 1 hour. That's why I can multiply by that. But my labels cross off here, my labels cross off here, and it looks like my number of miles would be over 3,600, which is 0.0 something. And now we can label like we would have expected to label a question, how far did the car travel? Now, because the question was how far did the car travel, leaving it as 244.8 miles per hour times seconds is not an appropriate answer. That is not does not tell me how far the car traveled. We would want to do that conversion right there. You could do it in miles, you could do it in, feet, because then it would actually make sense. That doesn't mean much to us, but it's true. 0.068 miles works. Questions? You have one on your assignment like this, so I would reference back especially to this part in dealing with those mixed units part of it as you guys are attacking that. Every assignment that you are doing from here on out, I don't want you to do these assignments for you. I don't want you to be doing chicken scratch and all of a sudden just magically having an answer appear. I want you to actually be like, okay, if I was trying to convince some AP reader that I knew what I was doing, that I would show all of my integrals with the correct notation. We've got to practice it. We've got to try it out. Compare your answers to mine and not just the final results, right? Because most of the time the final results is like 1 out of 5 points. You've got to get more than just that part of it. Get your communication across nicely. We don't have a lot of problems on this assignment, so you have plenty of opportunity here to take your time and show your work in an organized fashion on these problems. You're on 391 and then 3 through 9.